Hello guys, welcome back to this video. Here I'm going to tell you what problems you may face while co-registration of some subjects and how can you rectify that. We'll see the manual method of rectifying the problem, manually reorienting, and the other method is either using AFNI, you can skull script the brain, or using FSL you can skull script the brain. So we'll see all the three methods, manual, AFNI and FSL method. So that's about this video. So let's get started. So first let me tell you what is the problem. So I was just going through some of my pre-processing of some of the subjects, and I have done realignment at this stage, and I have also done co-registration. Now I am just checking the output after co-registration. Okay, so first I'm just checking the registration. So I have inputted the anatomical image over here, and then I'm inputting the resting state realigned image. Okay. Okay, so this is the anatomical image and this is the realigned image. Okay, so let me just show you the contour. Okay, so here you can see I've overlapped the contour of this image on this anatomical image, right? So now if you see closely over here, you can see that this red contour is actually a little downwards. Can you see that? Okay, I can also change the location so that it'll be maybe so here you can see it more clearly. If you see here, this line is very down as compared to this particular thing, right? So here they have been co-registered, but the co-registration output is not that good. I mean, there are some small major differences that you can see. So the first way that you can do rectify this is by using something known as reorient. So reorient this image. So I just want to reorient this functional image. So reorient this image. Okay, when you do that, you get an option over here. So you can move right, forward, up. Then you can rotate in pitch direction, roll direction, yaw direction, and you can also resize. That is, make it bigger or smaller. Okay, using this. Okay, so these are the different parameters that you can use. However, we just want to move the functional image up. Okay, so we'll use up and just try and change this and see what happens. So let's take 2. So I'm shifting the this image up by 2 millimeters. This is okay, but you can do still better. So let me try 4. You can see now it is a little bit more better, but I guess I should make it a little more, say 5. I guess 5 is okay. Yeah, I guess 5 seems fine to me. Let me see what happens with 6. Okay, 6 is a bit too more. You can see there is some skull over here. So let me keep it back to 5. Yeah, I guess this is perfect. So you can see these things are also now nicely aligned. This is nicely aligned. You can just change. You can see this is also very nicely now aligned, and just have a look at the other slices as well. Okay, so this is one way how you can correct the co-registration. So I would recommend you, if you have small number of images, that is say 10 or 20 image, do this manually. After every co-registration step, you should check the co-registration output and manually tweak them by using reorient, so that you make sure that the co-registration is perfect. Okay, so when you're done with this, say apply to image. When you do that, it'll ask you which all images do you want to reorient. Okay, so we want to reorient all the functional images. You can also reorient the mean image. So what I'll do is So over here I have the mean and the first slice. So let me start with second up to 152. Okay, I don't need to reorient these because these are the before realigned image. Okay, the original raw image. Okay, so you can just reorient the realigned image. Okay, press done. Then it asks you whether you want to save the matrix. So there's this matrix that will generate for this transformation. So if you want, you can save the matrix, or else you can press no. Maybe it is better to save the matrix. Possible that in further analysis you may require, or you may write somewhere that I reoriented this by this much up or whatever. So it is better to save it. Okay, so here it is reorienting now, and that's it. I mean, your images are reoriented. You can see now it's so beautifully realigned to the anatomical image. So this is one way that you can manually do the co-registration. So this may be difficult if you have a lot of subjects. Say if you have 100 or 200 subjects, then it will be very difficult to check the co-registration output of every subject. In that case, what you can do is, if you have a lot of subjects, you can do something known as a skull scripting. So by skull scripting, what happens is your skull of the anatomical image, you will remove that. See, if you can see, your normally the functional images don't have a lot of skull. Okay, they are mostly these brain images only. I mean, they may have some, but you can see mostly though they don't have. So what you can do is, you can remove the skull for the anatomical image, so that will give the algorithm a better reference. So that is one way. So I'll first show you how you can actually remove this skull. I'll show you two methods, one with FSL, the other with AFNI. So let's first see with FSL, how can we remove this particular skull with FSL. Okay, so what you have to do is, so here I'm in my WSL. FSL and AFNI only works with Linux, so for that you'll have to install this WSL. And in the WSL, go to the path wherever your particular this subject is. So first let me show you what is the name of the anatomical image. Let me go to the anat folder. So here I am in the anat folder, and here this is the name of this particular anatomical file. So what you have to do is type BET2 for FSL. So BET2 will use FSL. Okay, BET2 brain extraction. Then type the subject name or the anatomical image name that you want to skull script from. Okay, and then you have to type the output file. Okay, so let me just type F for FSL, and that's it. Just press enter. It's so easy. So once you do this, it'll take some time, and it's done. You can see it's done. Now if I just go to the folder, okay, so here it is. So if you see, it makes a .gz file. It is a zip file, so you can just extract the contents of this over here. So here you have the NII image. Okay, this is using FSL. You can do the same using AFNI as well. So for AFNI, the command is 3D skull script. Sorry, 3D skull strip. Then you have to put an input. Okay, so what input you want, this is a different syntax. That so here you did not have to put any input or something, but here you have to put an input and then type the name of the file that you want to give input to. Okay, and then you have to type prefix and then the output. Okay, so say let me use Z for AFNI, and just press enter. So this takes a little while depending on uh, which input file is it. I mean, how difficult is it to just remove the skull. So this might take 2 to 3 minutes depending upon the image, the input image. So what I'll do is I have already done this and I've saved this as a Z file. You can see that over here. Okay, so this is with AFNI, this is with FSL. Okay, so I'll show you now what is the difference between AFNI and FSL. So just press enter over here and you'll get the AFNI skull scripted file as well. Okay, now what you can do is I'll just show you the different images so that you understand the difference between AFNI and FSL and why one is slower and why the other is fast. Okay, so let me underlay the original anatomical image. This is the original anatomical image. Now I will overlay. So here is the FSL image brain extraction. So you can see this is how FSL has extracted the brain. Okay, you can see that there are some parts over here which are actually not exactly uh, taken out. So this part is remaining. You can see, I mean, FSL has just taken this part. It has cut out this brain portion. You can see that over here also. This much is the brain, but FSL just took this much. On the other hand, if you see the AFNI output, you can see AFNI is so perfect. You see, so beautiful. It is taking the entire brain and it is only removing the skull and all the other different things. Right. So that is the advantage of AFNI. So AFNI is very accurate, but it may take some while. On the other hand, FSL is not that accurate, but still, I mean, it'll give you an okayish kind of you can see over here, there is no AFNI, I mean, FSL brain. So that is the difference between AFNI and FSL brain extractions. FSL also does a pretty good job, but I mean, AFNI is a little more better. Okay, but AFNI takes a lot of time. So that is the trade-off between the two. However, we just want to co-register this to the rest image, so it is fine. I mean, you can just choose an option which depending upon how accurate you want to be, and then take a call. Okay. So once you have extracted this, so let me just quit. So once you have skull script, you can just co-register both of them again. So let's go to SPM for that. Co-register, estimate, reference image. So let me put the AFNI image over here. Oh, I'm in the wrong directory. AFNI image, the rest image. Oh, sorry. You just have to put the reference image over here. So I've done that. So the anatomical image is the reference image. Then in the source image, you will have to put the functional image. So either you can put the mean, and for other images, you can put this thing. Okay, press done. So I have 152 files over here. Here I have this. Okay, maybe I can just change this to 5. If you don't know what I'm doing over here, I recommend you to see my core registration video. I've explained in detail what all these steps are, and then press run. Okay, so it has done the core registration. You can see the output over here. Now let us again just check reg. Okay, now you can see this is a little more better. You can see that these are aligned properly as compared to one that was earlier. You can see this is better now. Okay, and now you don't need to reorient. Okay, so the only advantage of skull stripping is that you get this skull removed, so you just have the brain portion now, which can be more easily aligned with the functional image. Okay, so this is how you can do it with AFNI. The same goes with FSL. So I've done that. So with FSL, so here is the FSL. So I've aligned the FSL anatomical image with the rest image. So this is the FSL skull stripped image, and just let me, yeah, you can see it has done the job. I mean, it is more or less okay, but yeah, but that does the job. So this is how you can do it with AFNI and FSL. And that was the video, guys. I mean, I hope you liked this video. If you have any doubts, you can put that in the comments down below and I'll be happy to answer them. Thank you so much for watching. Thank you.